Hi, good evening everyone. This is Shefali Singla, and in this session we are going to discuss the last application of greedy technique, that is single source shortest path. So, as the name itself suggests that there will be multiple paths available, out of which we have to find out the shortest path. Shortest or the maximum longest और जो भी इस type की terms होते हैं ये तब हम use करते हैं when the values are given to us. Okay, so single source shortest path is nothing but this is the application of the graph. तो आपके पास एक graph है, you can consider this continent as as an input. तो इसमें हमें क्या करना है, आपको एक सोर्स से बाकी किसी डेस्टिनेशन पे पहुंचना है एंड देयर आर मल्टीपल पाथ्स अवेलेबल. हम शॉर्टेस्ट कब फाइंड कर सकते हैं, जब एक से ज्यादा पॉसिबिलिटीज हैं. Otherwise, simply we will be saying that there is a path from A to B if there is only one path. So that particular path will be the longest path as well as the shortest path. So shortest, particularly if we have to find out the shortest path, तो पहली चीज path exist करना चाहिए, and second thing is there should be multiple paths available जिसमें से हम shortest path find करेंगे. It's just like you are going from your place to some other place and there are multiple paths available. आप Google Maps check करते हो, so sometimes you prefer the shortest path. So it's just like that only. Okay, I have used here one term, there should be some path present. कोई path present होना चाहिए, तभी हम path identify कर पाएंगे, shortest path identify कर पाएंगे. तो ऐसा कौन सा scenario हो सकता है जिसमें path ही exist ना करे? Think about some scenario under which no path exists. Any idea? If there are two places which are disconnected or we have a disconnected graph, that means उन दो particular nodes के बीच में कोई path exist नहीं कर रहा, तो उस case में हम shortest path find नहीं कर सकते. What I'm saying is, let's assume that this is some place and there are two islands I and J. इनके बीच में आपस में कोई path exist नहीं कर रहा. There is no path from I to J because this is the graph G which is disconnected. Now you are getting a statement like you are supposed to find out the shortest path from I to J. What what will be your reply? It will be like there is no path from I to J. How can I find out the shortest path? So that's exactly the same thing that I'm expecting. So if the graph is disconnected, then in that case, we cannot find out the shortest path. So this is the first point here. Shortest path is not possible. Shortest path is not possible if the graph is disconnected. अगर ग्राफ डिस्कनेक्टेड है तो हम शॉर्टेस्ट पाथ फाइंड नहीं कर सकते. पॉइंट नंबर 1. Second point is, if we have a negative weight cycle present in the graph, we cannot find out the shortest path. We cannot find the shortest path if negative weight cycle exists. Can somebody tell me that what is this negative weight cycle? We cannot find the shortest path if negative weight cycle exists. Can somebody tell me that what is this negative weight cycle? मैंने यहाँ पे एक कंडीशन बोली है कि अगर आपके पास ग्राफ में नेगेटिव वेट साइकिल होगा तो हम शॉर्टेस्ट पाथ नहीं फाइंड कर सकते. सो व्हाट इज दिस नेगेटिव वेट साइकिल? डेफिनेटली इट इज समथिंग रिलेटेड टू अ साइकिल. कहीं ना कहीं ग्राफ में आपके पास साइकिल बनेगा एंड द वेट ऑफ दैट साइकिल विल बी नेगेटिव. लेट मी कंसिडर टू साइकिल्स. देयर इज a vertex A and B. From A to B, the path length is -3. Negative means कहीं ना कहीं negative आएगा. And B to A, this is 6. Other possibility is we might be having A to B. This is 3 and this is -6. Now we have to find out the path length. So let's assume that for A this is 0, यानी कि आप A से start कर रहे हो. I want to find out the shortest path to B. अभी तक B को visit नहीं किए, so definitely its initial value will be infinity. Now when I have to go to A to B, तो A तक पहुंचने के लिए जितना distance cover किया है plus whatever is the weight of this H. This is -3. So 0 minus 3 comes out to be -3. -3 is smaller than infinity. Yes, so I'll be updating this value to -3. Next, B से A जाने के लिए path is -3 to -3 plus 6. This comes out to be 3. Is that value greater than 0? Yes. So we won't be updating here. Shortest path find करने तो value कब update होगी? When we'll be getting the minimum value. So in this case, values are fixed. Up 0, -3, again it is coming out to be -3. That means there are no changes coming up. Let's look at the scenario 2. Here, if to reach to A, it's covering a distance of 0, then if it has to go to B, this comes out to be 0 plus 3, that is 3. Obviously, 3 is smaller than infinity. Whenever we get the shortest path, we get the minimum value, then we'll be updating the existing one. Next one, B तक पहुंचने के लिए आपने 3 यूनिट्स का डिस्टेंस कवर किया है और A तक पहुंचने के लिए B से A भी एक पाथ एग्जिस्ट करता है. बेसिकली देयर कैन बी मल्टीपल पाथ्स अवेलेबल. सो B से A भी एक पाथ जा रहा है. दिस इज सेइंग दैट B तक आने के लिए 3 यूनिट्स कवर किए हैं और वहां से A पे जाने के लिए यू हैव टू कंसिडर दिस एज एंड इट्स वेट इज -6. So 3 minus 6 comes out to be -3. Is this the smaller value than the existing one? पहले A तक पहुंचने के लिए 0 was there. Now it's -3. Obviously -3 is smaller. I'll update this value. Now again check when A is updated. जब A तक पहुंचने के लिए distance update हुआ तो बाकी सारी values भी update होंगी. So -3 plus 3 that comes out to be 0. 0 is smaller than 3. Yes, so again this value gets updated. Now 0 minus 6 यहाँ पे change हुए. A B से A पे भी edge जा रही है. So again we'll update this. 0 minus 6 0 minus 6 is -6. -6 is smaller than -3. We'll update this value. -6 plus 3 is -3. We'll update this value. -3 minus 6 is -9. So this way these values will keep on updating, right? तो इस तरीके से जब आप ये एजेस को कंसिडर कर रहे हो आपके पास ये वैल्यूज अपडेट होती ही जा रही है. एवरी टाइम वी आर गेटिंग अ स्मॉलर वैल्यू, राइट? सो व्हाई इज दिस प्रॉब्लम हैपनिंग? इफ यू लुक एट द साइकिल्स, दोनों केसेस में मैंने साइकिल बनाया हुआ है, बट इफ यू लुक एट द वेट ऑफ द साइकिल इज A to B and B to A. साइकिल होते हैं जब आपके पास सोर्स और डेस्टिनेशन सेम है, जहां से चले वहीं पे पहुंच गए. सो A to B this is -3 and B to A this is 6. So weight cycle, overall weight cycle comes out to be +3. And in case 2, when I'm considering the cycle, this is A to B and B to A. Now A to B path length is 3 and B to A path length is -6. That comes out to be -3. This means that this cycle is negative weight cycle. This is known as negative weight cycle. Negative weight cycle. कभी भी अगर आपके पास ग्राफ में नेगेटिव एज है तो सिर्फ नेगेटिव एज देखकर नहीं बोलना कि नेगेटिव वेट साइकिल इज देयर. In case 1, although negative edge is there, but still this is the positive weight cycle. So this will return you this shortest path. Shortest path कब नहीं find कर पाएंगे? When there is a negative weight cycle existing in the graph. Is this clear? Guys, is this clear? Now, there are few algorithms to find out the shortest path. Can somebody name those algorithms? Okay, don't worry about noting down all these things. If you are like busy in noting down the things, guys, don't worry, because after the session ends, I'll share this PDF in your Telegram group, that is Shefali Ma'am Testbook. तो जितने भी YouTube सेशंस होते हैं सबकी मैं PDF शेयर करती हूँ, तो आपको सेशन में सिर्फ और सिर्फ कॉन्सेप्ट के ऊपर फोकस करना है. डोंट वरी अबाउट गेटिंग द नोट्स. एंड इसके अलावा जो भी आपके डाउट्स और क्वेरीज होते हैं वो आप टेलीग्राम ग्रुप में पोस्ट कर सकते हो. यू कैन डायरेक्टली इंटरेक्ट विद मी, यू कैन पार्टिसिपेट इन द क्विज एंड द पोल्स एंड सो ऑन. Okay, so can somebody tell me that how many algorithms do we have for single source shortest path? There are two algorithms. One is the Dijkstra's algorithm and other one is the Bellman-Ford. तो हमारे पास दो algorithms है single source shortest path find करने के लिए. First one is Dijkstra's algorithm and second one is Bellman-Ford algorithm. Okay, so now we are going to start with the Dijkstra's algorithm. Whatever points I have written here, this is related to Dijkstra's algorithm. Shortest path is not possible if the graph is disconnected, तो कोई भी algorithm work नहीं करेगा. But जो second point मैंने बताया है, we cannot find out the shortest path if negative weight cycle exists. तो Dijkstra's algorithm will go into the infinite loop, because अगर negative weight cycle आ गया तो वो value calculate करता रहेगा and we won't be getting the result. So these are the points related to Dijkstra's algorithm. Now let us consider one example for better understanding under what scenario we can find out the shortest path. There is some graph A, B. Let's summarize what we have discussed. C, D, E, F, G, H, I, and J. This is the given graph. Obviously it will be directed, क्योंकि जब हम रूट की बात करते हैं तो डायरेक्टेड एजेस आती हैं, और क्योंकि हमें शॉर्टेस्ट पाथ फाइंड करना है, then definitely it will be having the weights assigned as well. For example, this is -10, 6, 5, 3, 4, 8. Now here I'm taking the other edge. This is -3, and here I'm taking the negative edge. This is -6. Now, okay, 4 more vertices are there. Something like this. -6, 8, 4, 9. Here, I'm assuming that A is the source vertex. Can somebody tell me that हम कौन सी vertex तक single source shortest path find कर सकते हैं? Single source means in the whole graph there will be only one source vertex. Or goal here is to find out the shortest path to every other vertex in the graph. तो एक फर्स्ट टाइप का क्वेश्चन कैसे आ सकता है? आपको कुछ ग्राफ गिवन होगा एंड they'll say that it's possible to find out the shortest path to every other vertex of the graph. There are few vertices to which we cannot find out the shortest path. So single source है तो there will be some source vertex given to you. I'm saying that A is the source vertex. Now in this case, to which vertex we can find out the shortest path? To what all vertices we can find out the shortest path. If you see here, it's A to B, it's -10. So the way is, जो भी source vertex है उसको 0 mark कर दो, remaining are infinity. Infinity means as of now these vertices are not visited. Source से start करके अभी तक आप इन vertex पे नहीं पहुंचे हो, so this is infinity. Now A is adjacent to how Dijkstra's algorithm is going to work. We are looking at that. A तक पहुंचने के लिए 0 distance cover किया. A is adjacent to B and C. So we can update these paths. 0, -10 0 minus 10 b तक पहुंचने के लिए आपने इस edge को cover किया. 0 minus 10 is minus 10. Is this smaller than infinity? Yes, so value gets updated. 0 plus 8, that comes out to be 8. Is this smaller than infinity? Yes, so it will be updated to 8. Next, whatever values are updated, b की value update हुई, b की value minus 10 है, b से अब d पे जाना है, तो what is the edge weight? That is 6. Minus 10 plus 6 is minus 4. Minus 4 is smaller than infinity? Yes, so this value gets updated. Now D is adjacent to -4. जो भी वर्टेक्स आपके पास डिस्कवर हो गए उनको उनसे आप उनको हिपिफाई कर सकते हो, मिन हिपिफाई कर सकते हो. कैसे करोगे? बाय कंसिडरिंग द एज वेट्स एंड बाय कंसिडरिंग बाय टेकिंग द स्मॉलर वैल्यू. -4 plus -3, that comes out to be -7. -7 is smaller than -10. -4 plus -3, that comes out to be -7. -7 is not smaller than -10, तो ये value update नहीं होगी. Next, -4 plus 5, -4 plus 5, that comes out to be 1. 1 is smaller than infinity, yes, so this value gets updated to 1. Now check for E. E is approachable from, I'm so sorry, I have taken the arrow in the same direction. This is -6. Guys, ये समझ में आ रहा है? As of now, I haven't got any response. Are you getting this point? So this is the edge from E to C. All right. Now, it's going from C to E. This is, okay. 8 plus 3, that comes out to be 11. 8 plus 3 is equal to 11. 11 is smaller than infinity. Yes, so this value gets updated to 11. Now E is discovered. अब E से outgoing edges, दो outgoing edges है. E to C minus 11 minus 6, that comes out to be 5. We are getting 11 minus 6, that comes out to be 5. Is it smaller than 8? Yes, so this value gets updated to 5. Similarly, 11 plus 4, that comes out to be 15. 15 is smaller than 1. No, this value won't get updated. Again, since here the change has taken place, so again I'll be discovering a new path. 5 plus 3 is 8. So 8 is smaller than 11? Yes. 8 minus 6 is minus 2. Sorry, 8 minus 6 is plus 2. 2 gets updated. 2 plus 3, 5. 5 minus 6, minus 1. Minus 1 plus 3, 2. Like this, these values are getting updated. And similarly, when these values are changing, then definitely the change could be taking here as well. Okay, तो जब यहाँ पे कहीं पे आपके पास negative value आ जाएगी, for example, -8 plus 4, obviously the change will be taking place here as well. Correct? तो इस case में we cannot find out the shortest path for C क्योंकि ये value update हो रही है. We cannot find out the shortest path for E because this value is also getting updated. We cannot find out the shortest path for F क्योंकि ये value भी update होती जाएगी. What about C, H, I and J? If you see here, A से शुरू करके क्या ऐसा कोई भी path exist करता है? I'm so sorry. A से शुरू करके ऐसा कोई भी path या set of edges है? Path is nothing but that's a set of edges. Is there any set of edges which we can follow and we reach to G? No, because this is disconnected from one part of the graph. Okay, so here this comes out to be infinity. यहाँ पे हम shortest path find नहीं कर सकते, तो हम ये बोल सकते हैं distance from A to G, or we can say that the shortest distance from shortest distance from the given vertex, distance to G will be infinity. We cannot find out the shortest path. For H also, we cannot find out the shortest path. For I also, we cannot find out the shortest path. For J also, we cannot find out the shortest path. For C, we cannot find out the shortest path. There are so many verses for which we cannot find out the shortest path. तो कौन कौन सी वर्टेक्स मैंने यहाँ पे मेंशन किए? एक तो ऐसे वर्टेक्स जो डिस्कनेक्टेड है, सेकंड वन इज व्हिच आर इन्वॉल्व्ड इन द नेगेटिव वेट साइकिल, दो फॉर दोज वर्ड्स वी कैन नॉट फाइंड आउट द शॉर्टेस्ट पाथ. Okay, so this is what I meant by the first two statements. तो आई गेस दिस इज वेरी इजी. एल्गोरिथम क्लियर है कि कैसे वर्क कर रहा है. जिस भी वर्टेक्स पे हो चेक करो. नेक्स्ट वर्टेक्स पे जाना है तो पर्टिकुलर वर्टेक्स तक पहुंचने के लिए जितना डिस्टेंस कवर किया है उसमें जो नेक्स्ट एज आ रही है उसको कवर करना है. सो विल जस्ट एड इट अप. Okay, that's the only thing. So this is all about the Dijkstra's algorithm. Let's take one example, then we'll look at the steps when we'll analyze the algorithm and we'll determine the time complexity. For example, we are given with a graph having 5 verses A, B, C, D and E. Guys, anyone having any doubt? अगर डाउट है आप एग्जाम्पल से पहले पूछ सकते हो. Yes, no, may or may not be. किसी को कोई डाउट? 4, 3, let's take one more edge. This is, let's say, 2 and 8. Okay, now I'm assuming that A is the source vertex. Have you revised the concept of the minimum cost spanning tree? Minimum cost spanning tree में मैंने दो algorithms discuss किए थे. One was the Kruskal's algorithm and other was the Prim's. So it's kind of similar to Prim's algorithm. What we are saying is, if we have to find out the distance from particular vertex to the adjacent of that vertex, for example source is A के adjacent B और C है, मुझे B और C का distance find करना है. तो कब value update करेंगे? जब direct value जो available है उससे smaller value हमें मिल रही है, because we are focusing on finding the shortest path. So what I'm saying is, if the distance from source vertex to some intermediate vertex plus distance from that intermediate vertex to adjacent vertex V, adjacent vertex is, let's say, B, and it's smaller than distance from the source vertex to adjacent vertex. जो direct path था उससे smaller value मिल रही है आपको, then we will be saying that we'll be updating the value. Then distance from source to adjacent vertex V will be updated to distance of source vertex to A, that is adjacent vertex, plus distance from A to adjacent vertex B. Okay, तो यहाँ पे क्या करना है? अगर आपको कुछ intermediate vertex, I'm assuming that A is some intermediate vertex, or let me take this as X. तो किसी भी intermediate vertex से अगर आपको shortest path मिलता है, then we'll be considering that path X to adjacent V. Let us apply this here. यहाँ पे हम क्या करेंगे? Same thing that we have applied in the Prim's algorithm. जितने भी vertex है सारे vertex ले लो, A, B, because ultimately we have to find out the shortest path from the source vertex to every other vertex of the graph. A, B, C, D, E. I'm marking all the vertices as infinity. सारे vertex को infinity mark कर रहे हैं. Infinity, infinity and infinity, except for the source vertex. Source vertex को I'm marking as 0. So this is 0, this is infinity, this is infinity, this is infinity and this is infinity. ये जो मैं ग्राफ पे मार्क कर रही हूँ, this is for our understanding, because memory के अंदर, system के अंदर ग्राफ के ऊपर mention नहीं होगा. This is going to create a table from all the vertices of the graph. Now, every time we'll be deleting the minimum value. So here out of 0, infinity, 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 definitely the relaxation will be taking place at the vertex A. So A will be deleted. A is selected. Now we'll check for the adjacents of A. A is adjacent to B and C for all the adjacents of A, that is B and C. क्या करेंगे यहाँ पे? Now 0 plus 10, that comes out to be 10. तो यहाँ पे value क्या है? 0 to 10. 10 is smaller than infinity? Yes. So this value gets updated to 10. This value मैं दोनों पे update कर रही हूँ 10. 0 plus 3 is 3. This is the smaller value than infinity. D or E से connected. D and E are not adjacent to A, so will not be updating these values. Now, from the existing values, we have to again delete the minimum value, that is for the C. So C is, relaxation order is, after A, we are deleting the C. C is adjacent to three vertices, B, D and E. To B, this is going to 3 plus 4. अब आपके पास intermediate vertex आ रहा है. Source vertex was A. Source vertex was A. Intermediate vertex is C. This was source vertex. Intermediate vertex is C. C and adjacent of B is adjacent of sources A was B. तो अब आप A to B path find कर रहे हो via C. So this is A से C आने के लिए 3. 3 plus 4, that comes out to be 7. Right? तो यहाँ पे वैल्यू क्या आ रही है आपके पास 3 plus 7. This is less than source to A to B distance was 10. This value is smaller, so we'll update the value here 7 because we are getting a smaller value, right? C is also adjacent to D. 3 plus 8, that comes out to be 11. C to E, 3 plus 3, that comes out to be 6. 6 value gets updated here. Again delete the next minimum. Minimum value is 6, so E will be deleted next. Now E is adjacent to D. सिर्फ एक ही outgoing edge is 6 plus 9 is 15. We won't be updating this value because as of now we are getting 11. Correct? So we won't be updating this value. So E is not going to make any changes. Then next comes the minimum value, that is for B. D. That is shortest path is 7 to B. So B is deleted next. And after that B is adjacent to D. That is 7 plus 2 is 9. So this value gets updated to 9 by B. After that D will be taken. This means that the relaxation order in this case is relaxation order is A. सबसे पहले A आया, then A to C. This path is discovered A to C, then C to B, and then there is C to E and B to D. So we have got the shortest values. Less than this is not possible. So relaxation order, if they're asking for the relaxation order, this is A, C, E, B, D. Relaxation order पे भी question आ चुके हैं. Once it was asked in the GATE exam. I think आपने देखा होगा. Otherwise, I'll be discussing that question in the master class. ये clear हुआ? Guys, is this clear? So this is the working of the Dijkstra's algorithm. Let's identify what should be the complexity. So step 1 mein, what we are doing is we are marking the distance to source vertex to 0 and to all the vertices distance. Okay, I guess I shouldn't write this step. Wait a minute. So first step में हमने क्या किया? We are marking the distance for every vertex, distance to all the vertices of the graph. We are marking this as infinity for all vertices V, and after that distance to source vertex we have marked as 0. After that we are looking for the adjacents. for the source vertex, and from that we are constructing the min heap tree. Construct min heap tree, because every time we are deleting the minimum value, min heap tree, I'm calling this as Q for all vertices. For all vertices. Next step. After that, we have to delete one by one all the vertices from the tree. So while जब तक tree आपके पास खाली नहीं हो जाता, यानी कि तब तक आपने सारी vertices include नहीं किए, while Q is not equal to 5, while the tree is not empty, till then what we have to do is we need to delete the minimum value, extract min. किस में से? Heap tree में से. I'm calling this as जो भी vertex delete हुई है, I'm calling this as U. Now we'll be looking for the adjacents of U for all adjacents of adjacents are, let's say V. For all adjacents of U, we have to find out the shortest path, right? तो यहाँ पे हम क्या कर रहे हैं? Extract min. We are looking for distance from U to V. U to X. X is some intermediate vertex, and if distance from X to V, that is the adjacent vertex, is less than the distance from U to V, then we are going to update this value. Distance from U to V, हमें smaller value मिल गई, so we will be updating that value. U to X plus distance from X to V. Exactly same thing I'm writing here what we have discussed here कि कब हमें value update करनी है. If we are getting any value, then update it, then definitely it will be making changes in the heap tree. And after that, we will be just deleting the values one by one. So this will be the end of the while loop. What will be the time complexity? फर्स्ट केस में हम ये बोल रहे हैं फॉर ऑल द वर्ड्स ऑफ द ग्राफ, जितने भी वर्ड्स हैं सबके लिए हमने कुछ वैल्यू इनिशियल वैल्यू असाइन की है, सो दिस विल बी टेकिंग ऑर्डर ऑफ बी. This was the same as that in Prim's algorithm. Then next one is construct min heap tree for all the vertices. Number of vertices will be V. So आप build heap method say this will be taking order of V. Order of n is the time complexity for build heap method. So I'm assuming that the min heap tree is constructed using the build heap method. Then while Q is not equal to 5, जब तक ये ट्री खाली नहीं होता, एक वर्टेक्स को डिलीट करने के लिए Q में कितने वर्सेस हैं? While means min heap tree में आपके पास V वर्सेस हैं, so this while loop will be executing for V times. Now I'm deleting one element from the min heap that will be taking log V time. After that, for all the adjacents of V, worst case में कितने adjacents होंगे? If we are having a complete graph, then we say that every vertex is connected with every other vertex. So this operation will be taking place for how many times? Worst case में V minus 1 times. And we are calculating the smaller value. If it is there, then we have to heapify the tree. हमें adjustment करनी पड़ेगी. For that, it is going to take log V time, because log V levels are there in the min heap tree. Now we need to find out the time complexity. This is V, this is V, this is V into something. So obviously the time complexity, overall time complexity will be focusing on step 3. Let's find out the time complexity for step 3. V times execute हो रहे. Under this we have log V. After that, there is for all the adjacents of V. So it comes out to be कितने adjacents हो सकते हैं? There can be V adjacents. And for each adjacent, we are looking for the smaller value, log V. Simplify this, it comes out to be V log V plus V square log V. We have already discussed that in worst case scenario, V is approximately asymptotically equal to E. So we can say that this is V plus E. It's going behind the image. Wait a minute. Okay, so this comes out to be V plus E log V. So this is the time complexity. Time complexity of this algorithm is order of V plus E log V. यहाँ पे हमने कौन सा डेटा स्ट्रक्चर यूज किया है फॉर हिपिफाइंग द एलिमेंट्स, दैट इज द min heap. So we can say that this is using the heap. Okay, but here there is one drawback with the Dijkstra's algorithm. So if negative weight cycle is there, then it is not covered. So drawback of Dijkstra's algorithm, its negative edge cycles are not covered. So this is all about Dijkstra's algorithm. Anyone having any doubt? मुझे कमेंट्स आपके दिख नहीं रहे हैं, कमेंट्स आ ही नहीं रहे हैं. So after this, next we have the Bellman-Ford algorithm, because there is a shortcoming in the Dijkstra's algorithm. That is, it does not covers the negative weight cycle. But graph में आपके पास negative weight cycle हो सकते हैं. So in order to overcome this drawback, we are going for the Bellman-Ford algorithm. So I can say that according, so that's for the Bellman-Ford. According to uh, Bellman-Ford algorithm, according to Bellman-Ford algorithm, if negative weight cycle exists, तो क्या कोई भी algorithm shortest path दे सकते हैं? Not possible, but at least it will report that negative weight cycle is present in the graph. Although even it cannot return the shortest path, because if negative weight cycle is there, then shortest path is not possible. So it cannot return the shortest path, but it will find out the negative weight cycle in the graph. It will find out the shortest path. Otherwise, if there is no negative weight cycle, then it will find out the shortest path. Otherwise, it will point out that negative weight cycle is present in the graph. Negative weight cycle is present in the graph, and it will return some path, not necessarily the shortest path, but it will return the path present in the graph. So it will find out some path, but uh, uh, but that path may not be the shortest path, but not the shortest path. तो कुछ तो path return करेगा, but not necessarily the shortest path. Let's see how this Bellman-Ford algorithm is going to work. I'm considering here one graph with 4 verses, because this is quite lengthy one. तो आपको बस complexity पता होनी चाहिए. And the working of Bellman-Ford algorithm, I'm taking a small example with 4 vertices and 4 edges. This is 2, 3, 3 and -6. So if you observe here, I'm taking an example which contains a cycle, and the weight of the cycle is the negative weight. So this is a negative weight cycle. Initially start कैसे करेगा, जैसे Dechkastra's algorithm work कर रहा है. So it is going to take the vertices A, B, C and D. Initially the source vertex, if A is the source vertex, so this will be marked as 0 and remaining vertices will be marked as infinity. Now what Bellman-Ford algorithm is saying, आपने हर vertex के लिए initial values assign कर दी, that's fine. Now we have to execute, we have to run the same steps for n minus 1 times, where n or v represents the number of vertices. This is the number of vertices. In this case, we have 4 vertices, so I'll be executing this for loop for 3 times. कितने times execute करेंगे? 3 times, because the number of vertices are 4. Now, in this case, every time we'll check if we are getting the minimum value. क्योंकि initially minimum value आ रही है, update करनी पड़ेगी, but there should be some restriction on updating the value. Basically, Bellman-Ford क्या कर रहा है? Infinite loop में नहीं जाएगा. It is going to put the restriction कि इससे ज़्यादा बार कुछ x number of times execute करेगा. That x is nothing but that is equal to the number of vertices. अगर last time में भी changes आ रहे हैं, that means there is somewhere negative weight cycle exist in the graph. Otherwise values could have get stable. Okay, so v minus 1 times के लिए हम क्या करेंगे? We are going to consider the edge, each edge. For each edge we'll check for the minimum value. Distance of v is greater than the distance of u. कुछ intermediate vertex लेकर आपके पास distance small आ रहा है. So we are going to update that value. This means that let me call this edge as E1, this is E2, this is E3 and E4. So I have marked the edges. Now let's consider the edge weights. E1 के लिए U is A and V is B. Destination. So 0 plus कौन सी edge consider कर रहे हैं? E1. We are considering the edge E1. 0 plus 2, that comes out to be 2. Initially these values are infinity. तो इसका change किसके ऊपर आएगा? B के ऊपर. B2 is smaller than infinity. Yes, so this value gets updated as a result of E1. This comes out to be 0 to infinity and infinity. Now consider the next edge. Next edge is E2. So 2 minus 6 is minus 4. So here we are getting the value minus 4. Minus 4 is smaller than infinity. Yes, so this gets updated. क्योंकि E2 का इफेक्ट सिर्फ और सिर्फ किसके ऊपर हो रहा है? C के ऊपर, तो इसलिए बाकी की सारी वैल्यू सेम आएंगी. दिस इज E2. E3. E3 will be changing the value for B if it's getting the minimum value. So minus 4 plus 2 is minus 2. Minus 2 is obviously smaller than 2. So this comes out to be minus 4 plus 3 is minus 1. So we are getting here the value minus 1, minus 4 and 0 and infinity. Now consider E4. E4 किसके बीच में? B और D के बीच में. B का distance minus 1 है. Minus 1 plus 3 is 2. So this value updated to 2. For each edge, we have updated the values of the vertices. This is about the first iteration when I was equal to 1. This is when I is equal to 1. Now next cycle when I is equal to 2. Again, we are considering all the vertices. This is A, B, C and D. For E1, for each edge we have to consider E1 का change किस पे आएगा? B के ऊपर. 0 plus 2, that comes out to be 2 only. Is the 2 value smaller than minus 1? No. That means it is not going to change the value of B. B की value change नहीं की. E1 ने कोई effect नहीं डाला. E2. Minus 1 plus minus 6, that comes out to be minus 7. बाकी सारी values as it is. Minus 7 plus 3, This value is now updated to -7. -7 plus 3 is -4. वापस से ये value change हुई. -4, -7, 2 and 0. E4. -4 plus 3, D की value change होगी to -1. -1 is smaller, so this is 0, -4, -7. This is updated for I is equal to 2. Second iteration. कितनी बार execute करने? For V minus 1 times, 3 times. So now I'll be taking next iteration I is equal to 3. Let's see if again the values are getting updated. A, B, C, D. E1 कोई change नहीं कर रहा. 0 plus 2, obviously this is smaller than the negative value. So it's not going to change it. Here we are going to get the value as 0, -4, -7 and -1. Now take the next value. Take the next edge, E2. E2 exists between B and C. C के ऊपर impact आएगा, so it will be updating this value to -10, 0, -4 and -1. After that, -10 plus 3 is coming out to be -7. So obviously -7 is smaller. So E3 is making a change here. -10 and -1. Then -7 plus 3, that comes out to be -4. So the value of D gets updated to -4. This is for E4. -10. This iteration is also over. Now for the last iteration, आपके पास 4 verses थे. Last iteration में check करेंगे, is there any edge which is changing this value? अगर वापस से आपके पास value change हो रही है, E1 में कोई change नहीं आ रहा, so it will copy the values. For the fourth iteration, E1 में there is no change, -7 and -1. But when we are considering E2, तो C की value smaller मिल रही है. So this condition gets true. So it will simply print that negative weight cycle exists in the graph. तो इसे समझ में आ गया कि इस point में जो आपने ये edge consider की है -6, that is E2 is contributing to the negative weight cycle. So this is saying that negative weight cycle exists here. Negative weight cycle. So by this time, it has updated some values with the shortest path. तो यहाँ पे अभी कुछ तो आपके पास values आ रही हैं. These are representing the distance from the source to some vertex, but not necessarily the shortest vertex, shortest path. So this is how Bellman-Ford algorithm works, right? Now let's talk about the time complexity. I hope that this is clear to everyone. अब क्वेश्चन ही आएगा मैम एग्जाम में इतना बड़ा पूछेंगे, इतना लेंथी क्वेश्चन आएगा? बिल्कुल नहीं आएगा. मैंने बहुत छोटी सी एग्जांपल ली है विद 4 वर्सेस एंड 4 एजेस, और तब भी आपके पास इतने स्टेप्स आ रहे हैं. तो ज्यादा से ज्यादा क्वेश्चन आपके पास जो आ सकता है दैट विल बी फ्रॉम द टाइम कॉम्प्लेक्सिटी. So if you see here, this was the step 1. For each vertex, we are updating some value. We are initializing it with some value. So that will be taking order of V time. After that, we are executing a loop. For loop, कितने times execute हो रही है? V minus 1. So this is V minus 1 times. This for loop is executing for V minus 1 times. Now for each edge. For each edge means this for loop is executing for E times. We are updating the value, right? For each edge, this is step 2, this is step 3. This is executing for worst case में कितनी बार execute करेगी? For E times. Anyhow, V into E will be greater than V into, this is a nested loop, right? So V into E is greater than this E times. So we can say that the time complexity for this algorithm is order of VE. Okay, number of verses तो उतने ही रहेंगे. Best case और worst case में difference क्या आएगा? In the number of edges. So if I talk about this, so we are saying that it's order of VE. In the worst case, we will be having more number of edges. That means we might be given with a dense graph. Dense graph means more number of edges. Dense graph means more number of edges. More number of edges means dense graph में worst case में हम ये बोल सकते हैं number of edges are equal to number of Every vertex is connected with every other vertex. So in this case, we can say that E is approximately equal to V square. Other possibility is we might be given with a sparse graph, means minimal connectivity है graph में, तो we can say that number of edges will be approximately equal to minimum connected graph में number of edges are equal to V minus 1. So I'm saying that it's, let's say, V minus 1. So on the basis of this, we can say that E is approximately equal to V. तो बेस्ट केस और वर्स्ट केस में टाइम कॉम्प्लेक्सिटी कैसे आएगी? दिस इज बिहेविंग एज अ वर्स्ट केस, dense graph is behaving as a worst case, so we can say that the time complexity will be V into number of edges are equal to V square. So I'm replacing this E with V square. Or we can say that in the best case, it's V into V. This is about the Bellman-Ford algorithm. Clear? I hope that this is clear to everyone. So this is all about single source shortest path, and with this we have finished all the applications of the greedy technique. So we started with the fractional knapsack, then we talked about Huffman coding, optimal merge pattern, then I discussed minimum cost spanning tree, job sequencing with deadline, and finally single source shortest path. We will be having one more application based on the shortest path, that will be all pairs shortest path. That's the application of dynamic programming. So after this, from tomorrow onwards, we'll be covering the concepts of the dynamic programming. That is the third algorithm designing technique in the algorithms. Okay, so if you want to get this PDF, I'll be sharing this PDF in another 5 minutes in this Telegram group, so you guys can join it. Telegram group is Shefali ma'am Testbook. Rest, you can find the link of this group in the description of the video. तो YouTube वीडियो की डिस्क्रिप्शन में जाओ, थर्ड लिंक इज द लिंक फॉर द टेलीग्राम ग्रुप. इसके अलावा जो भी आपके डाउट्स हैं, अगर आप प्रैक्टिस क्वेश्चंस कर रहे हो, देन यू कैन पोस्ट योर डाउट्स इन द टेलीग्राम ग्रुप, और यू कैन ज्वाइन द मास्टर क्लासेस जो डेली 8 बजे होती है. दैट्स द जस्ट हाफ एन आवर सेशन जिसमें हम लोग PYQs कवर करते हैं एंड आई टेक योर क्वेरीज. Apart from that, you can directly interact with me, you can participate in the quiz and the polls. So from tomorrow, we will be discussing the dynamic programming, and tomorrow we will be covering the first application. Just आपको समझ में आए कि dynamic programming कैसे work करता है. We'll be talking about 01 knapsack. अभी भी मैंने knapsack का नाम लिया था. That was fractional knapsack or real knapsack. That's the application of greedy technique. But 01 knapsack is the application of dynamic programming that we'll be covering in tomorrow's session. Let me quickly share my slide. So that you get to know where is this link available. So when you go to this video, just go to its description. Here in the description, you will see first link is for the master classes. आप master class को यहाँ से join कर सकते हो. NIC super coaching, अगर आप NIC exam पे focus कर रहे हो, get super coaching telegram. This is the link I was talking about. This is the third link. Fourth link is join super coaching gate. So when you click on this link, it will take you to the textbook homepage. यहाँ पे मैंने CSE select किया हुआ है, so just go to the CSE, and in the super coaching you will be getting the complete course in the recorded format. पूरा का पूरा course recorded format में available है. आप अपनी pace पे अपनी convenience के according recorded sessions को follow कर सकते हो. Once you are done with that, then you can join the live series. In the live series, we will be having the sessions on each and every topic. We will be having a quick revision of each and every topic, followed by the doubt solving session and the PYQ session and practice session. And apart from that, under the super coaching, you will be getting the study notes for each and every subject. Detail notes मिलेंगे, formula notes मिलेंगे, detail notes revision के लिए, which contains the concepts, and those concepts are explained with the help of the examples. जो formula notes है उनमें सिर्फ और सिर्फ important formulas और notes है जो revision के time पे काम आएंगे. So let's quickly go through what all courses are available. आप एक ही सब्जेक्ट, एक ही टॉपिक को मल्टीपल एजुकेटर से पढ़ सकते हो. यू विल गेट एन नंबर ऑफ एग्जाम्पल्स एंड क्वेश्चंस. एंड जब तक आप सेटिस्फाइड नहीं हो अपनी प्रिपरेशन से, टिल देन यू कैन कीप ऑन वॉचिंग द नंबर ऑफ सेशंस, सो देयर इज नो रिस्ट्रिक्शन ऑन दैट. If I talk about the full length courses, full courses subject wise courses bhi hai. Full length courses mein we have the course, complete course by Gate Forum, by Digimento, by Nimbus Learning, and by Testbook and its team, by me and the team. So 250 plus videos are available under this batch. You can view that, and yeah, so this is there. You can go through the live series, you can go through the test series. Test series is also covered in the mock test, subject wise test, length, topic wise test. Starting topic wise test से होगी. पहले हम topics prepare करते हैं, फिर subject prepare करते हैं, फिर हम mock length test पे आते हैं. So that's a step by step process for the complete preparation. Study notes, as already discussed with you, study notes are available in the PDF format. Computer science engineering में आपको detail notes मिलेंगे. हर unit के ऊपर अलग से एक PDF बनी हुई है, तो it's segregated. आपको worry करने की जरूरत नहीं है कि ये notes कहाँ से मिलेंगे. And second thing is, अगर कोई unit बहुत lengthy है, lot many concepts आते हैं, तो उनके लिए separate PDF बनाइए. जैसे computer networks में 10 units नहीं है, but still we have created 10 PDFs ताकि आप चीजों को relate कर पाओ. And all the kind of numericals will also be solved in these detailed notes. Second category of the notes is the formula notes, जिसमें आपके पास सिर्फ एक ही PDF होगी per subject, because one PDF is more than sufficient. It is just containing the important set of formulas. जितने भी formulas उस particular subject से या important points चाहिए वो होंगे. Difference between the detail notes and the formula notes is, डिटेल नोट्स में हर पॉइंट एग्जाम्पल्स लेकर डिराइव किया गया है, और फॉर्मूला नोट्स में डायरेक्टली गिवन है. ओके, तो फॉर्मूला नोट्स हम सिर्फ रिवीजन के टाइम पे प्रेफर करते हैं जब एग्जाम आ रहा होता है, otherwise not required. But revision के टाइम पे it's very very important, क्योंकि if you are going through the detail notes, then you might be wasting your time. And we have the notes for the engineering mathematics. 7 plus PDF are available. You can go through it. मैं इनको इससे ज़्यादा explore नहीं कर सकती, because these are under the subscription and as of now it's not activated yet. And general aptitude के notes भी available हैं. Just go through it. Okay, complete information is available here. Just see, these are the completed live series. ये already हो चुके हैं. आप देख सकते हो यहाँ पे concept through questions, concept through a question series is there, PYQ and MCQ series is there, doubt and revision session. तो ये जो topics होते हैं ये आपके पास live sessions में आते हैं. Okay. Now, practice entry, यहाँ पे आपको practice questions मिलेंगे. And next one is the pricing. So there are 4 plans available: 9-month plan, 1-year plan, 2-year plan, and 3-year plan. So 1-year plan is for 11,249. ये जो आपको prices दिख रहे हैं, these are after the discount. Okay, discount के लिए what coupon code you have to use? So it's given immediately after the super coaching link, that is Shefali, SHEFALIS. Okay. So you can just go to the apply coupon and replace your whatever coupon is there with the Shefali S, and you can get any of the subscription. Basically 1 year or 2 year subscription में रेफर करूंगी आप लोगों को, और जो लोग 2024 पे टारगेट करेंगे 2024, guys you can go for 9-month subscription. आपको 1 year की भी जरूरत नहीं है. But if you are targeting on 25, that means you might be in the 3rd year, then you can go for 1 or 2 year plan. और जो लोग सेकेंड ईयर में, उनके लिए भी मैक्सिमम 2 year plan should be sufficient, because 2 साल बहुत होते हैं to prepare the GATE exam. Anyone having any doubt or query? Now let me quickly discuss the schedule. Guys, any doubts or queries? So Monday to Friday, we are having the sessions on YouTube and the masterclass. YouTube session timing is 4 p.m. ये fixed है slot. YouTube 4 p.m. to 5 p.m. इस सेशन में हम सिर्फ और सिर्फ कॉन्सेप्ट्स करते हैं और जो क्वेश्चंस हैं दोज आर कवर्ड इन द मास्टर क्लास. This is on the Testbook platform, but definitely you need not to have any sort of subscription. These master classes are completely free for everyone. So you can join the session at 8 p.m. This is from 8 p.m. to 8:30 p.m. In this, we are covering the previous year questions. Saturday and Sunday is for the ISRO sessions, PYQs. Usually, यहाँ पे ISRO से related PYQs मैं cover करती हूँ on the YouTube. Okay. But definitely these sessions are only on Saturdays and Sundays. तो ये स्ट्रक्चर अभी के लिए हम फॉलो कर रहे हैं. जो ये वाले PYQs हैं जो हम डेली करते हैं, these are the gate. But इसके लिए I will suggest you guys to go through the concepts which we are covering on YouTube. जो concepts मैं YouTube पे करवा रही हूँ उसी से related previous year questions हम master class में कर रहे हैं. तो इसका एक benefit ये भी है कि आपको topic by topic PYQs मिल जाते हैं. Although PYQs बहुत सारे sources से आपको मिल जाते हैं, but topic by topic and with proper explanation and discussion you will be able to solve these PYQs. So if you want to follow these classes, you can join it from Monday to Friday. Today we will be having the session at 8 p.m. in which we will be covering the previous year questions from greedy technique. क्योंकि last week हमने greedy technique की applications की थी, सिर्फ एक ही application हमने आज cover किए. So PYQs on greedy technique will be covered in today's session. Yes, there is no query. आज वाली जनता जो है वो completely mute mode पे है. They don't want to interact. So that's perfectly fine. But hope to see you in the masterclass at 8 p.m. Guys, please be on time because this is just half an hour session. अगर इसमें भी late आओगे तो फिर कुछ बचता ही नहीं है. Okay? So try to be on time. Thank you so much. God bless you. Bye bye.